Welcome to this explainer. Okay, we're diving straight into this today because we are taking a massive journey across the globe. Literally.
Yeah, we're exploring how geography isn't just about memorizing capitals, it's this incredible interconnected science that links the rocks deep beneath our feet to the political borders we see on our maps.
Exactly. We aren't just looking at where things are. We really want to dig into why they are there in the first place and how the entire Earth basically acts as one massive, dynamic operating system. So here is how we're breaking it all down today. We're going on a micro to macro journey. First, inside the Earth, then continents and oceans, followed by the climate systems. Right. And then from there, we look at geography and civilization, dive into environmental geography, and finally, wrap up with the future of geography. All right, section 1, inside the Earth, the engine of our planet. You know, it's so easy to walk outside and think of Earth as just this static, solid rock. But it's really a moving machine.
A very hot, moving machine. Right at the very center sits the inner core. It is a solid ball made of iron and nickel, and it's roughly the size of the moon.
Which is wild to picture inside the Earth. But the craziest part is the temperature. It sits at a staggering 9,000 degrees Celsius.
To put that into perspective, that is actually hotter than the surface of the sun.
This is literally where all the power of our planet begins. So surrounding that superheated inner core is step 1 of our layers, the liquid outer core. This layer churns constantly, and that movement is what creates the magnetic field that protects our atmosphere and keeps us alive.
Then, moving up to step 2, we hit the mantle. This is massive. It's a layer of slowly convecting rock that makes up 84% of Earth's total volume. This is the engine driving plate tectonics.
Which brings us to step 3, the crust. This is our fragile little home. It's only about 5 to 70 kilometers thick depending on where you are.
I always love this analogy. If the Earth were an apple, the crust we live on, build our cities on, and fight our wars over would be thinner than the skin of that apple.
Moving right along to section 2, continents and oceans, the surface stage. Up here on the surface, the sheer scale of these landmasses is just breathtaking. Let's talk numbers really quick.
Yeah, Asia alone spans 44.5 million square kilometers. It's home to 4.6 billion people. That's over half the global population on one continent.
And then you have Africa, holding the massive 9 million square kilometer Sahara Desert. We've got North America with the towering Rocky Mountains and the Great Lakes.
South America holds the immense Amazon rainforest covering about 5.5 million square kilometers. Plus, there is Europe's incredibly dense, historically significant landscape.
And we can't forget Antarctica down at the bottom, just quietly locking away 90% of the entire world's ice. These landmasses also host some unbelievable extremes. Think about Mount Everest, towering at 8,849 meters. And remember that moving mantle we talked about earlier? The Indian tectonic plate is still actively colliding with the Eurasian plate right now, meaning Everest isn't just sitting there, it is actually still growing. It's a live planet for sure. We also have the world's great rivers. The Nile stretches a mind-boggling 6,650 kilometers across Africa. And the Amazon River in South America, which moves more water by volume than literally any other river on Earth. But you know, water isn't just in those giant rivers. We call Earth the blue planet. But there's a major catch, a huge catch. 97.5% of our water is salt water, which means all of humanity, every farm, every city, every forest ecosystem relies entirely on that razor-thin 2.5% slice of freshwater to survive. Still, those vast saltwater oceans are absolutely vital. They cover 71% of our planet's surface. To put that vastness in perspective, the Pacific Ocean alone is 165 million square kilometers. It's so deep it hides the Mariana Trench, which drops 11,000 meters down into the darkness. And these oceans aren't just big bathtubs, they act as massive climate regulators, moving heat around the entire globe through vital, continuous currents like the Gulf Stream. Now returning to our precious freshwater, look at how concentrated it actually is. This stat always gets me. Just 2 systems on the entire planet hold nearly half of all the surface freshwater. You have the Great Lakes in North America holding 21% and Lake Baikal in Siberia holding 23%. It really highlights how vulnerable our water supply is and how incredibly important these specific regions are to the globe. All right, section 3, the climate systems, heat, wind, and weather. So because the Earth is a sphere, the sun hits it unevenly. This creates these very distinct zones based on latitude.
Right. Near the equator, from 0 to 23.5 degrees, you have the hot, humid, tropical zones, like the Amazon and the Congo.
Move a bit north or south, and you hit the subtropical zones, then the temperate zones between 35 and 55 degrees latitude.
And noticeably, this temperate zone, with its 4 distinct seasons, is actually where the vast majority of the developed world currently resides today. Finally, past 66.5 degrees, you hit the freezing polar zones.
Now, these zones are heavily influenced by fast-moving air currents like the jet streams and regional events like the monsoon.
Yeah, and we should clarify what a monsoon actually is, because it isn't just a heavy rainstorm. It is a massive seasonal shift in wind patterns.
Exactly. This shift dictates the agriculture and, frankly, the survival for billions of people in places like India and Southeast Asia. And then we have the deserts. They cover a full third of Earth's land surface.
And here's a really surprising takeaway about that. When we say desert, most people immediately think of intense, blistering heat.
But deserts are actually defined by a lack of precipitation, not by heat.
That is exactly why the Sahara in Africa is a famously hot desert, while the Gobi in Central Asia is actually a freezing cold desert. It's all about the lack of rain.
Section 4. Geography and Civilization. Where we live and why. So, how do these oceans and weather systems actually dictate human history? I want you to really ponder this question for a second. Why do civilizations form exactly where they do?
Yeah, why are human populations clustered so heavily in places like East Asia, South Asia, and Europe, while other huge areas remain empty?
It really comes down to a core concept called geography as destiny. Basically, people are practical. They settle where survival is the easiest.
Right. You need a moderate climate, you need fertile land to grow food, and you need transportation routes. That is why history's greatest civilizations all sprouted along major river systems.
You see it with the Nile, the Yangtze, and the Ganges. The geography literally provided the blueprint for those societies to thrive. And this dynamic creates a massive ongoing divide between landlocked nations and coastal nations. Historically speaking, landlocked countries have really struggled with economic growth simply due to a lack of port access for trade. Meanwhile, having access to the coast gave birth to absolute economic megacities. We're talking about Shanghai, New York, London, Mumbai, and Tokyo. A coastline is basically an incredible economic amplifier. Geography doesn't just build cities, it draws our political maps too. Think about the Himalayas or the Pyrenees Mountains. They serve as giant natural walls between nations.
And then you have resources. Oil in the Middle East or mineral deposits in Africa entirely dictate regional wealth and, sadly, human conflict.
But here's the thing. Humans are resilient. We don't always accept our geographic destiny.
Not at all. If a continent is in our way, we dig the Panama Canal to cut it in half. If an ocean is in our way, we build the Channel Tunnel to drive trains right underneath it. We constantly hack our geography.
Which brings us to Section 5, Environmental Geography, a Changing Planet. This is where things get really urgent. Human activity is fundamentally altering these geographic systems, and we are literally watching our maps change in real time. As global temperatures shift, melting glaciers are causing sea levels to rise. This directly threatens the existence of island nations like the Maldives and Tuvalu. We're also losing 10 million hectares of forest annually, largely in places like the Amazon. And those vital rivers we talked about earlier, rivers like the Colorado and the Nile, are draining. They're under immense water stress, which impacts 2 billion people globally. It's a huge threat to biodiversity in places like Madagascar, too. The physical systems are under incredible pressure. Section 6, the future of geography.
Tomorrow's map.
So what does tomorrow's map actually look like? Well, by the year 2050, a massive 68% of the world's population is projected to live in urban areas.
We are rapidly becoming a heavily city-dwelling species.
Add to this the very real trend of climate migration, where people will be forced to move as certain regions become less habitable. It becomes so clear that through migration and globalization, our world is going to be far more interconnected than at any point in human history. We want to leave you with this powerful thought. Geography reminds us that we're all connected. The decisions we make in one part of the world have ripples across the globe. From the shifting tectonic plates right beneath our feet, to the ocean currents, to the political borders we draw, Earth is one single, fragile, and deeply interconnected operating system. We now understand how it works, but as we look to a future of changing climates and shifting populations, the ultimate question is, how will we choose to program it next? Thank you so much for joining us for this explainer. Keep exploring, and we'll see you next time.